Welcome, everyone. So let's get started with today's lesson. Are there any ideas about this Maths 24 puzzle before we properly get going with the content? Anybody willing to have a crack at it? If you are, put your suggestions in the chat. It would be most helpful, and there's much glory to the person who can solve it. And then while we are, can we, Anya, send out the poll about how many students today is it their first lesson, and how many students, if we could just have well, maybe a bit early for that, but if you could send that out in the next minute or two.
Okay.
My suggestion for the blue one is 7 minus 3 equals 4 would be a good place to start with the blue one. See if you can get to 24 using that idea. And then a warm welcome to Michle, to Mbali, to Jared, to Kamvaletu. Welcome, guys. It is great to have you with us. Excuse if I'm peering to the right side, but my chat panel is on my other screen. Okay, who's got a suggestion? What should I do to get to 24? We're going to ignore this one for now. That's no longer a concern. I just want to do the blue one.
Sorry, so I'm taking a while. It's just I have to quickly set up the polls, but I've nearly got it done. But you can carry on.
Yeah, I realized I didn't actually set I didn't set them for grade 11. But yeah, that's fine because we need to wait till students are here anyway. I'm still waiting for my first 8 times 3. In Bali, you're on the right track. The problem is we have to use the numbers 1 and 7. So whilst you've got to 24, you have to use all 4 numbers. Any other ideas? Who else can get us to 24? Well, actually, you know what? Maybe 7 minus 3 is 4. And then we need to 6. Maybe that isn't the most helpful thing in the world. Actually, let me see if I can remember this. 8, 7 minus 3 is 4. For some reason, I've forgotten this myself. Who's going to help me get over the line here? So we could say 7 minus 3 is 4. Oh, there we go. 7 minus 3 is 4. And what is 4 minus 1? It's going to be 3. And now I can go 3 times 8 is 24. So I think I've done that right. Have I used all 4 numbers? Let's check. 7, 3, that got me to 4. 4 minus 1 is 3. And then 3 times 8 is 24. So that is our little warm-up question. And to those of you who are new today, welcome. It is great to have you here. My name is Peter, or you can call me Sir or Mr. S. And Anya is in the chat. She's also a maths teacher, and she is answering your questions in the chat. And so we are basically the maths teachers running this lesson, and it's great to have you with us. We're just going to do some admin and announcements. So the first thing is, with Watobe, you get a 2-week free trial. And if you have enjoyed that 2-week free trial, or you found it helpful, you need to let your parents or guardians know, because they get a message from Watobe after 2 weeks asking them if they would like to continue. There's a various sign-up fee. I think the sign-up fee is, it's 75 Rand a week or 300 Rand a month. And so it's important that if you enjoy it, you let your parents know. Otherwise, they may just think they're being spammed by, a company. And so that's the basic announcements. And then the other thing is the website is the most important thing for Watobe. So when you get a basically when you have a login and a password on the Watobe website, you have access to the Zooms, you have access to the previous recordings. That's a really important part of using Watobe, is getting a profile on the website. So please, if you haven't got that already, make sure that you do. And if you are finding it helpful, some of you, this may be the last week of your free trial, please do let your parents know so that they don't think they're being spammed if they get a message, because yeah. All right. Most of you know who we are. We're not going to go into a full introduction. And so I'm going to start with today's lesson and explain what this unit is about. So this unit is about circle geometry. Okay, so circle geometry. And in some senses, geometry is really about two things. It's about straight lines. And so a lot of grade 9 and grade 10 is about straight line geometry. And, you know, straight line geometry is just about the relationships that form when you get straight lines. Circle geometry is a lot about when we add curved lines and we add straight lines together. Now, that's a huge simplification, but basically, and the shape that we focus on with curved lines is the circle. And so today's lesson is really going to be about just checking what you know about circles and just sort of uploading the important details and getting you familiar with that. And then the section actually is quite an important section going forward. And each week we will build on things. So let's start with a fun question. You have 4 options. In a circle, what is the name of the straight line going from the center to the circumference? And you need to vote in the chat. Is it, or put your answer in the chat. Is it A, B, C, or D? I want to see. I want to see what you see. So in a circle, what is the name of a straight line going from the center to the circumference? If you want to visualize this, here's my circle, here's my center, and I'm going from there to the circumference. What is that called? All right, I see that people are onto this. No problem. Time for the next question, I think. In a circle, what is the name of a straight line that goes from one point on the circumference to another? It's a little bit harder. In a circle, what is the name of a straight line that goes from one point on the circumference? So maybe I could say, here's a point on the circumference, here's my center, that goes from one point to another point on the circumference. So there's quite a lot of possibilities. We could have that, or we could also have maybe something like that. Which one is most correct? A little bit trickier. Okay, so it may be a diameter, but you don't know for sure. All you know is something else. It's another special word. So think about, is this possible? So I have my circle, and here's the center, but it doesn't say anything about the center. It just says, what is the name of the straight line that goes from one point on the circumference? Now, the circumference is the perimeter of a circle. Here's another point on the circumference. Now, is that line called the diameter? I don't think it is, because it's not going through the middle. And it didn't say anything about going through the middle. So the special word for that sounds a bit musical, but it's actually called a chord. And so the answer would be 1D. This is called a chord. Now, a very special type of chord is a chord that goes through the center. And the chord that goes through the center is indeed called the diameter. But if it just says it goes from one point on the circumference and it's a straight line, it's going to be called a chord. Okay, so that's one to just keep in mind. It'll come up many times, don't worry. So number 3, I've kind of given the answer away for this. What's the answer for number 3? Oh, sorry, guys. I made it fly. May probably make you dizzy. Okay, you're perfect. Indeed, it is the diameter. Because I've added the constraint that it's up 2 points on the circumference, but you have to go through the middle, and that makes it a diameter, or 2 radii. A very famous formula that is important to remember, and I'm sure many of you have heard this in grade 9, but 2 times the radius is the diameter, or another way of writing that is r plus r. Okay, so that's an important formula. That's an important relationship. In a circle, 2 radiuses will always give you the diameter. And we're going to explore many other types of relationships that are hiding in a circle that you would never guess. Okay, now, before I do that, what's another famous formula from a circle? What if I'm really interested in knowing the perimeter, or what we might call the circumference of a circle? What relationship have you heard about before that I might need to keep an eye on? Is there a relationship between the diameter and the circumference? Does anybody know? So in Paul, the unit today is on circle geometry, and we're just kind of taking a little bit of a leisurely tour through the vocabulary that may be involved. Is it correct to say diameter divided by 2 is radius? Yes. Convaletu, that is exactly the same thing. But what I'm very interested in knowing is there a relationship between this thing called the diameter and the circumference? Anybody know? I'm going to pause a little bit because it's quite an important one. And so if you imagine what is the relationship between those two? What do you guys know? I'm sure somebody must have heard of it before. Any ideas, Anya? What do you think?
Just say again, so sorry, you cut out a bit.
So I'm interested in knowing, if I think of a circle, the circumference, I'm giving the letter C, and the blue line is the diameter. It's a chord that goes through the center of the circle. What numbers or what things might be involved? Does anybody know? Well, I was just thinking, Anya, what does this look familiar to you?
I know there's something so that starts with a 3, and it's a decimal number.
Yes. What's that funny number? Everyone, all the maths people always seem to go on about. Yeah. There we go. It looks a little bit like a wonky hippie number. You know, like it looks a bit, what do you think of my pie? So a very important relationship in circles is the diameter times pi is the circumference. And we approximate pi to be about 3.142, but it actually goes on forever because it's an irrational number. So this is another relationship that if you took 3.14 diameters and you put them around the outside, they would stretch all the way around the outside. Okay, so this is just some of the basic ideas that come up in circles. Today is all about just bringing them back into your memory. Let's do another question. And some of this vocabulary may be new to you, and that's the point of today. What is the name of a 4-sided shape that has all its corners or vertices on the circumference of a circle? And I want you to vote, even if you don't know for sure, which one do you think it is? What is the name of a 4-sided shape that has all its corners or vertices on the circumference of a circle? And, to visualize this, try and visualize it for yourself. Here's a circle, and all the points are on the circumference of this circle. And it's a 4-sided shape. So that's, I guess, one way that it could look. So that's one way. I guess if I wanted to be nasty, I could put them a little bit, like this, and maybe I could do it like, like that. What type of thing is that going to be? Okay, so I see A's, I see C's, I see A's, parallelogram, D's. Well, a parallelogram would have to have two parallel sides. So what a four-sided shape is called, first of all, a four-sided shape, if that's all you know about it, it's called a quadrilateral. So quad for four, quadrilateral. And a cyclic quadrilateral is a four-sided shape where all its vertices are on a circle. And so the answer is going to be C, a cyclic quadrilateral. Now, this word cyclic quadrilateral will come out again, but for today, all we want to know is that it's a quadrilateral where you can basically put a circle that goes through all four points of that four-sided shape. Okay. Let us continue our little journey here. Oh, I got lost. What's happened to my stuff? Oh, here we go. Okay. So when we deal with circles, what is the name of a line that touches a circle in only one place? Put your answers in the chat, please. We're only going to do 7 of these. So it's all about getting the vocab going. What is the name of a line that touches a circle in only one place? So let's imagine this. Here's a circle. How would a line touch a circle in only one place? This line would touch the circle in 2 places. This line wouldn't touch the circle at all. But this situation, if I just got it right, it would touch the circle in only one place. Lock your votes in, everyone. It's time to commit. It's time to play the game show. Okay, I think most of you seem to have worked it out by like elimination. So the fancy thing over here, the answer is D. And this thing is called a tangent. Okay. Sometimes you hear people talking about someone who's talking too much and they've gone off on a tangent. That's because it comes from the word tangent, where this straight line is just going to come to the conversation, touch it once, and then carry on going, and no one's listening. So that's where that phrase going off on a tangent comes from. It comes from the physical tangent on a circle. Now, this situation over here, where it cuts it in 2 places, this is called a secant, and it cuts the circle in 2 places. And this over here is just called a line because its relationship is separate to the circle. Again, you don't have to memorize everything today, but I do just want you to start hearing these words. Okay. Question 6, answer in the chat. What type of angle is 30 degrees? Is it an acute? Is it obtuse? Is it a right angle? Is it a reflex angle? So in geometry, there's lots of words. We have to understand what they mean. And so this is an important, okay, I think you guys have got this. An acute angle is, the answer is going to be A. And just to remind you what an angle is and what an acute angle is, an angle forms when we have a vertex where 2 lines meet, like this. And if you think about what the angle measures, it measures the amount of turn between the 2 lines. So like, how much would I have to turn the one line, how much would I have to rotate it to get to the other one? And so we get different types of angles. Oh, I managed to make my thing confused. If the angle is less than 90, so if the turn is less than a quarter, it's going to be an acute one. And so 30 degrees is an acute angle. An obtuse angle, what would that look like? An obtuse angle would be greater than 90, so it would look like a laid back angle. I always think of it like a deck chair. Notice how this angle is going to be obtuse, whereas this angle is going to be acute. A right angle is like kind of standing straight up like this. And then a reflex angle is basically the angle that makes up the rest of a revolution. So the reflex angle of 6, if this was 30 degrees, the reflex angle would have to be this one, which because a revolution is 360, the reflex angle would be 330. If my obtuse angle was 150, I want you guys to work this out. If my obtuse angle here is 150, what is the reflex angle over here going to be? Put it in the chat. What's the reflex angle of 150 degrees? Pop it in the chats. Just the act, guys, even if you get this wrong, just the act of committing to the process and being an active learner does help you even retain, even if you got it wrong, when you see the right answer, you'll retain the right answer better. I know I'm asking you to put a lot in the chat, but it really does have a beneficial effect. Okay, so what you do is you go 360 minus 150, and you get 210. You're absolutely correct. Okay, and then I think this is our last. I've already done this one, so that's okay. Let's do number 8. More vocabulary. What is the supplementary angle of 30 degrees? Show me. What do you get? Is it A, B, C, or D? I'm really hitting you with the vocab today, but what does it mean if two angles are supplementary? Okay, you guys know your stuff. So supplementary means add up to 180. And so if you've got 30, the supplement of 30 will be 150, which is C. Okay, and then that is, I want to throw one more in just because I'm a math teacher and I can make this up on the spot. What is the complement of 30 degrees? Who knows what the complement of 30 degrees is? So not the supplement, what's the complement of 30 degrees? And I don't mean like, oh, 30 degrees, you're looking great today. I mean, what is the value of complement of 30 degrees or?
Sir?
Yes.
While we do that, can I show the kids something that I used to do when I was still teaching?
Yeah, go for it.
So you need to see me for this. So when we're doing these, right, and someone gives you a compliment, you say, thank you. And that gives you 90 degrees. So when someone gives you a compliment, you say, oh, thank you. So it needs to add up to 90. Another one, you want to be big and strong, and you want to take supplements, right? So you can flex like this. That adds up to 180. That's just something I used to do when I was still teach. If it made you laugh, if it made you cringe, you'll always remember it. And that's my rule of thumb. Back to you, sir.
It's always like that. Like the things that like stick in your head, they're like worms. So you're quite right. So in the complement of 30 is going to be 60 degrees because it adds up to 90, essentially. So that's great. Okay, guys. So that is a little bit of vocab. Like I said, in case you came on late, today is all about understanding circles. And so I actually want us to, let's take a quick break. So let's just take a quick break and stand up. And then we're going to try and label some different parts of a circle. But at first, I want us to stand up and just stretch, because there's been a lot of just straight talking by me. And so what I want you to do is I want you to, let's see if you can see me. I want you to do this pen flipping thing again. I know you've done it before, but trust me, I've taught enough classes to know this helps your brain reset. So I want everybody standing up. So move away from your table, let your body be free, and grab a pen that you can toss up into the air, and I'll explain what you do with it now. And so the whole point of this is that your brain focuses intensely on the pen flipping, and it forces your brain to let the maths go and relax and unwind just for 2 minutes. And it actually resets your attention span. We know from studies on the brain that our brains need a chance to just relax and process what we've learned. And if we allow them the chance to do that, they really, they behave a lot better. Okay, so the way it works, grab one end of the pen, you toss it in the air, and all you want is to catch it on the same end and have one full rotation where it goes in the air, flips over, and you catch it at that next end. So you go, oh, almost got it. Oh, I'm bad today. If you think that you're a ninja at this, then I challenge you to use your non-dominant hand to do this, in which case that would be my left hand. I toss it in the air and I try and get it to do one rotation. Well, that wasn't too bad, although I didn't catch it on camera. Let's see if you can see this. Oh, it goes below the camera, but that's the idea. The other trick is if you can get a heavy pen makes this much easier. And so if you can avoid a pen like this, oh, right here. So here is a marker that I have, like a marker like this. I'm looking at the wrong thing. If I take the end with a cap, pick it up, and then I can do it. Oh, it's so much more satisfying that way. Oh, anyway, if you manage to do it just once, give us a thumbs up in the chat. If you're finding it like, oh my goodness, this is next level, give us a thumbs down in the chat, and then we're going to continue. But I know from experience, even for me, I just feel so much. If I've been sitting at a table and learning for 25 minutes, I always force myself to stand up and to do something to let my brain unwind. And in future lessons, I'll show you some other tricks that I have to help you unwind. Maybe you can even tell your teachers at school. You can tell them, I need a brain break. That's what it's called. Okay, so let's jump on board the circle geometry train again. I want you to try and identify the different parts of the circle. So we are going to we'll call this A, this B, this C, this D, and this E. And I want you to label the parts of the circle and put them in the chat, please. And this goes to our main goal for the day, to just get more familiar with the circle. I feel like the circle doesn't get the attention it deserves in grade 9 and 10. It gets a bit neglected, but that's all going to change in grade 11. And so we need language to describe the things we're going to see in circles.
So just while we add it, I'm just having a look at the image. For the students that are a bit confused, if you want to see what E is pointing at, E is pointing on the outside line. That's all I'm going to say.
Yeah, so E is pointing to the outside bits. Maybe I should even put this, so E is pointing to that. There are actually two answers you could use, because you could ask, does the thing go the whole way around, or does it just go part of the way around? But for now, that's a bit of a debate. A refers to this, B refers to, let me get a different color. B refers to this. I think C refers to that. And then what else do we have? I'll use black again. Maybe I should use different color highlighter. Those are all my colors. This is D. And then E is kind of the yellow bit, but it actually depends on if it goes the whole way around or not. And I'm going to draw a little bubble here for the names of the things. So I agree, C is definitely the center point. I always get confused how you spell center point. I think it's an American English, British English thing. So this is called the center point of the circle. And in a circle, the center point is a big deal. B is not the radius, but it's close. I think the radius would be D, because the radius goes from the center to the edge. So for me, the D is the radius. But then what does B have to be? Pop it in the chat. Who else has some ideas? I'm sure you guys have some ideas. Who knows what A is? We were talking about it a little bit earlier. Okay, so B is going to be the diameter, because B is a chord that goes through the center of the circle. Oh, I've given away A. So A is a line that goes from one point on the circumference to another, and the word for that is chord, and C-H-O-R-D. Now, E is actually, I would say E is probably the best way to describe it is the circumference, but there is another special word that we could use if the curved line doesn't go the whole way around. A circumference means that this thing goes, oh, so excuse my rather colorful marker. A circumference means that the thing goes the whole way around. But what happens in the situation where it doesn't go the whole way around, where it only goes part of the way around? What would the word be in that situation? Who knows the word for part of the way around a circle? Mbali, you are smashing it. So if you only go part of the way around a circle, a curved line part of the way around the circle is called an arc. Okay, so E could be either the circumference or the arc. So just to show you all the vocabulary, and again, this will come up again and again and again, but if we look at the parts of a circle, these are some important bits of vocabulary that we need to get used to. So I think most of you are comfortable with the radius, the diameter, and the circumference. No problem there. But this one today, the chord is definitely new to a lot of you. And I want you to just take a moment and think, what makes a chord a chord? An arc is simply a part of the circumference, but you'll notice that the arc has one point on the circumference and another point, and it goes along the curved part. So these are new words to a lot of you. And then the word tangent that came up earlier. So that's new. And then what are these strange things over here? Segment and sector. What those words are words that stand for parts of a circle, parts of area of the circle. So the way I think about it is a segment and a chord are very closely related, because a chord divides a circle into what's called a major segment and a minor segment. The smallest of the two pieces is called the minor segment. So that's definitely new. And then a sector actually needs two radiuses. It's almost like an orange, like a sector of an orange. And the same thing here, you get the major sector, and then you get the minor sector. And a sector has more to do with an arc. But I think these are not super important, but it's good to know them. Okay, so that is some vocabulary. Let us move on a little bit.
So,
yeah.
My dogs aren't too loud. But anyway, just on that note of a segment, just something maybe if you want to maybe just zoom into the image of the segment, please.
Yeah.
So what would happen, right, if you start at the circumference and you draw your chord through the center to the other side, so that looks like a diameter basically, and then you color 1/2 in. Would that be a segment or would it be a sector, and why?
Oh, wow. That's a good question. Does everybody get that? So what happens at that point? Everyone, can you see that? So what happens if I draw a line straight through the middle? So in that case, you've cut the circle perfectly in half. And so actually it could be either, but the most important thing, I think, is that this is going to be a semicircle. So the special word for a circle cut in half is a semicircle, because this area over here could be seen as a sector, or it could be seen as a segment. And it could be either. Very good question, Miss Anya. I very much think you'll get a gold star for that. I like that. Are there any other, I wonder while we're here, are there any other questions? Let's open up the floor to questions. So, or even the chat. Do you have some questions like Ms. Anya's question now about like what happens in this situation? Or I've heard about this thing, what's this called? Because I feel like I've kind of got you into the way of thinking about circles now, but there may be things that you've heard about that you don't really understand. So if you'd like to ask a question, put your hand up and you can say it audibly, or type it in the chat.
So we've got a question from Michle.
Okay.
And Michle asks, does the segment cut through the center point?
Okay. It does not have to. It can do, but it doesn't have to. So I'll give you an example. If I think about this, the center point is over here. You have one segment up here. This is called the minor segment. And then on this side, on the other side, we have the major segment. In this case, it's not going through the middle. But in the situation that Ms. Anya described, say like this, then these two are going to be of equal size, and the segment would go through the middle, but most of the time it won't. But that's a nice question.
But, sir,
yeah,
do you mind if I just jump in here as well? If we define a segment as basically a chord and an arc, right, that makes a section, and you say, for instance, like on the right-hand image, the last image you drew, the segment goes to the center, then technically that's not a segment, that should be a diameter, correct?
Yeah, but it's actually both at the same time. So it's kind of, think about this. Think about membership criteria to get in a club. If you can you be members of two clubs at the same time? You can, as long as you meet the membership criteria. And so there are situations like this, which means it's both at the same time. Yeah. Cool. All right. So that's enough about that. But I think it's good to just throw vocabulary in as we go. What I want to do now is I want to finish the lesson with, actually, before I do that, let's do that. So I want to ask you this question. And again, I know today's heavy on vocab, but it says here, O is the center of the circle. Is angle ACB a central angle or an inscribed angle? And so what I'm going to do is I'm going to ask you to vote on this. If you think it's a central angle, make it A. If it's an inscribed angle, vote B in the chat. And so we've got the situation, we've got A, B, and C, and we've got this angle, and you need to decide, is it a central angle or is it an inscribed angle? So we're talking now about angles within a circle. Okay, Emikle, good question. What is an inscribed angle? I haven't told you, but I'm just asking you to guess for now, because today is really about introducing yourself to some of these words. A good thing to ask yourself is, what would a central angle look like in a circle? And then if it's not a central angle, what else could it be? There's a nice mixture of answers. I just want to give a little bit more time. Even if you don't know, just guess. So is the angle ACB? Here it is. So there's ACB. Is that angle a central angle or is it a inscribed angle? And we don't really know exactly what the words are yet. We just know that I'm using fancy words. Okay, so the answer to this question is going to be B. So B is the correct answer, because a central angle has to be at the center. So to show you what that looks like, if I started at, let me just get a different color, so I get blue. If I start at A and I start at B, and I draw my lines to here, I'm not forming my angle at the center of the circle. So it can't be a central angle. However, if I form my angle at the circumference, it's then called an inscribed angle. Now, that is quite a fancy word. So sometimes in South Africa, what we often, sorry about that, guys. We often call these words an angle. So an angle at the center. So angle at the center. And that would be a central angle, or we say an inscribed angle is an angle at the circumference. Sorry, guys, if you can't see this perfectly, but this angle would be called an angle at the circumference because the angle is made at the circumference. Does that kind of make sense? And so an angle at the circumference is also called, another word for that is an inscribed angle. It's inscribed inside the circle. And if that helps you understand it, it's made inside the circle, but it doesn't go to the center. Okay, what's the term for when you draw the circle inside the angle? I'm not sure I understand the question, Laurentio. Maybe a later question will help. Well, let me just draw a little diagram. So what are the different scenarios that can happen? I guess should be a good question to ask yourself. So I have a circle and I have a center point. Okay, and often the center is called O. Now, if I want to have an angle, in order to have an angle, I always need 3 points, right? And to start with, I need 2 points. So let's start with having these 2 points here. And we'll call these 2 points A and B, like we did previously. Now I have a choice. If I choose to make my third point O, that would be an angle formed at the, sorry guys, if you could just be on mute for now, then we'll ask you to, this would form an angle at the center. However, if instead of forming an angle there, we form an angle at the circumference, so that's one possibility. Or we could even draw, and we call that point C. I think I lost you guys for a second there, but basically, C, this is called an inscribed angle or an angle at the circumference, if it's on the circumference. And if the angle is formed at the center, it's called a central angle or an angle at the center. And I think the best way for us to, I will repeat. So whenever you start with 2 points and you form an angle at a third point. If that third point is on the circumference, it's called an angle on the circumference or an inscribed angle. If that third point is at the center, then it's called an angle at the center or a central angle. And that's all you need to know for today. Just that you can have an angle at the center or you can have an angle at the circumference. Okay, I want you guys to look at this drawing for a moment and ask yourself how many points are there? And then I want you to ask yourself, how do I identify an angle? Normally when I identify an angle, I use 3 letters or I use labeling. But the sort of the basic way we would do it is if I wanted to identify that angle, I would call it POQ with a little hat on top. If there were labels, if there were numbers there, like if there was a little 1, then sometimes you see people call it O1, but there's no numbers there now. Now, the question is asking you, in the circle, identify the inscribed angle, and I know this is quite wordy, and the central angle, subtended, okay, that's a weird word, we'll talk about that later, by the same minor arc. Now, I'm going to identify the minor arc for you. Remember the word arc from previously? So the minor arc is going to be the arc that travels from P to Q. So let me just make my pen a different color. That is going to be the minor arc. It's going to be PQ. Subtended really just means to form a base. And I want you now to ask yourself, can you find the angle? What is the angle at the circumference? So that's what this means. And what is the angle at the center? And can you write that down in the chat? So we'll call this A and this B now. But just think about it. P and Q are the 2 points that I'm using to form my angle. If I formed an angle at the circumference, what would that look like? I think it would look like that. Does it have PQ as the base for the angle? Yes. How would you write down this angle over here with the green dot? That's the first challenge. I want to see if you can do that. So the angle at the circumference is going to be this one R, and it comes from the same minor arc PQ. So how are we going to write down this angle over here? There's 2 ways you could write it. It could be PRQ, or you could write it as QRP. That is the inscribed angle, or the angle that is made at the circumference, which is here. Now, what about the central angle? How would I, or the angle at the center, how would I describe that if I have to use the same minor arc PQ as the base? What would it look like? So if that's my base, I have to go to the center. So what is this angle over here going to be called? Give you a moment to think about that. I see a hand. Please go ahead. And who is that? Who has their hand up? David. Go ahead and ask a question, David.
Sir, I don't quite understand 2.2. I actually don't know what's really going on.
Okay. So first of all, from the beginning, is there a circle here? Step 1, yes. Is there, I'm drawing your attention, David, to this this thing called PQ. And that we're going to call a minor arc because it's an arc and it's the smaller of two ones. If I use it as a base, I can take this as a base and make an angle at the center. Notice how I'm using the 3 points, P, Q, and O. I'm making an angle at the center. And what I'm asking students to write down is that angle is called the central angle. And so what is it called? And I see some people have written it in already. The central angle will be called POQ, or it could also be called QOP. And that will be the angle formed at the center. And then the angle formed at the circumference is just going to be the one with that focuses on the R, which goes down. So if you think about PQ as the base, the angle at the circumference is going to be this red one here. So I hope that's a little bit helpful. Does that kind of make sense?
It helped me.
Fantastic.
Yes, sir.
The power of colors, I tell you. A good diagram and colors. Way to go. Okay, I think we're going to do one more of these, and then I think I've hit you with enough vocab for one day. Okay, do I want to do that one, or do I want to do another one? I just want to make a choice. See what the other ones are. Oh, that's the last one for the day. Okay. So this is a bit of a challenge one. So point O is the center of a circle. Arc AB is a semicircle, which means it goes half the way around. What is the measure of angle AOB? So we're going to end today with this question. And then for the last 5 minutes, I'm just going to take questions from people who want me to clarify stuff from the lesson. Emekle, I think you've got it. How did you know so quickly? So Emekle's got an answer, which looks pretty good to me. How did you know so straight line? Exactly. So if it's a straight line, you know that all straight lines add up to 180 degrees. And so even if you got the one on this side, well, what would the reflex angle be? It would also be 180 because together they add up to 360. And so we call this an angle in a semicircle. The angle in a semicircle will always, well, okay, it's not, yeah, actually, I'll talk about that in later theorems, but you automatically know that this is 180 when you've got a diameter. It must make an angle of 180 at that point. Okay. I've hit you with a lot of new words and new terminology. I'm just going to finish by going over a few of those words, and then I will dismiss the class. But anybody who would like some extra question time, we will stay on until 7. So we've still got quite a bit of time. Just to explain minor and major arc. So say that I have 2 points, A and B. This, if you think about going along here, this is the minor arc, and then so the yellow one is the minor arc, and then the major arc is going to be the green one. So I hope that helps a little bit. Then, if we imagine using the minor arc as a base for building angles, and this is what the last question was kind of asking about. If I make an angle at the center using the AB as a base, this is called, over here, this is called an angle at the center of the circle, for good reason, because it's made at the center of the circle. If I use the base AB, and I say that AB subtends an angle, it just means it's basically supporting the angle, it's building the angle. If I subtend an angle over here, that is called subtending an angle at the circumference, because I'm making an angle at the circumference. And often what you'll do is you'll see that the letter O is used for the center of the circle, and then maybe we'd use the letter C, but that can just be general letters. So there's quite a lot of particular vocabulary, and I don't really want to go further than that today. I will spend the next lesson kind of bringing Euclidean geometry and and this part together. But I think for today, that's enough stuff. But I will take questions now in the chat or audibly to help smooth over any unsureties. So I'm going to stop now in terms of official capacity, and I'm just going to ask for questions. But while we do questions, Kamvaletu, there's no quiz today. There's only a quiz on Wednesday. So for those who are new, we do a quiz, a fun quiz on Wednesdays every week. Today is just a straight learning and then extra question time. But Anya, while we do question time, can you send out a couple of polls related to what devices the students are using and these types of things, and just take screenshots? And then I will take questions from the students. I see David's hand is up. So David, go ahead with your question.
Sir, do you mind if you scroll down? I want to take screenshots.
Okay, like this one?
Yeah, this one, down. The other one.
You mean like that one?
The previous one before, yeah, that one.
Oh, that one, yeah.
Can go, yeah, this one.
Yeah. So the good
you.
today is that we're going to, today is the warm-up lesson. So we're doing a whole bunch of these. And every week I'm going to add some new vocabulary to you. So you're like, today's new words were like angle at the center, angle at the circumference, chord. These are all words that we will practice again in the next lesson. But I just wanted to introduce you to this new world of circle geometry today. I think we did a pretty good job of that. And if you feel unsure, don't worry. You'll hear these words many times.
Sir, there's two questions in the chat. One question we had quite a while ago. Laratu wants to know, what's the term for when you draw a circle inside an angle? Or I think she meant an angle inside a circle.
Okay, well, if we have a circle, one of the words we had earlier is when you draw an angle inside a circle, it has to be formed at either two places. It's either going to be formed at, the angle is going to either be formed at the center, or the angle is going to be, oh wait, I made a mistake there. The angle is going to be formed at the circumference. So that's what you could be talking about. Or earlier in the lesson, we spoke about a four-sided shape with all its sides on a circle, and that's called a cyclic quadrilateral, because a circle goes through all 4 points. And so that's called a cyclic quad. Often they use quad with a dash there.
And then the next question from the chat is from Nokwanda, and Nokwanda's asking, I think it's about that last drawing you did, so you can scroll down a bit, the one that's at the very bottom.
I think that's it, yeah.
I think it's still loading. No, below. There we go. So Nokwanda's asking, sir, is the angle at C and the angle at the center equal?
Oh, that's such a good question. Okay, now I'm afraid it's like a good TV show, you know, when you can't give the ending away. So I was setting you up for that question, and I'm so glad that you noticed. Unfortunately, I can't tell you today, but I am so impressed, Nokwanda, that you noticed. Can I just say, pause, coming to a place near you soon, because it's a really important question, and I'm just going to highlight it without answering it. If we have a circle, and then we have an arc, or even you could draw a chord, and we draw an angle at the center, and we draw an angle at the circumference, what is the relationship between these two angles? Are they the same? Are they different? Is one bigger? Is one smaller? And this is going to come up in future lessons. So I'm very impressed that you answered it. But for today, I'm just going to say, I wonder. Okay. Anybody else?